Good afternoon. This is a special weather discussion focused specifically on what the heck happened to the winter of 2019 and 20. So we're going to cover a couple of things, and I'm just going to get right to the point with this video of exactly what caused the epic bust. Okay, this winter is a lot like the movie Godzilla in 1998. That's the name of Godzilla. It is advertised as Godzilla, but it was no Godzilla. And any Godzilla fan, as you could tell I'm a huge Godzilla fan, would know that that movie was a horrendous disaster. This winter was called winter. It was advertised as winter, but it was no winter. And I know that I've heard of a lot of disappointment, in some cases anger, from a lot of snowplow individuals and just people overall who love winter weather. And quite frankly, there's also a lot of people that depend on their livelihood that there is a lot of snow. Okay, that it's an active winter weather season. And if they're told, hey, this season looks like it has the opportunity of being very active with above normal snowfall or at the very least above normal storm activity, then they're going to prepare for it. So I completely understand the anger in some cases and disappointment. Meteorologists and along with my forecasts and others out there definitely saw the signs of the potential for a very impressive winter weather pattern. Now, in terms of tropical forcing, I could rule out tropical forcing, at least in my forecast. And the reason why is that the idea of this being a warm neutral season panned out just right. The MJO being volatile panned out pretty much as expected. The SOI, which is what we watch out for with active, when it goes negative, that means that there's a greater chance of storms on the East Coast. When it goes positive, more likely of a trough towards the plains or the west, and that's going to be variable. All that worked out into subtropical gesturing. When we had plenty of storms, they just happened to be rainstorms, okay? So the question of the winter, where was all the cold air and why did it get locked up? And the idea going in, and I'll show this right now. Let me pull this up. Okay. So the winter weather forecast was based on the idea that the polar vortex was going to be disrupted. And in the forecast, I put down at the end wildcards of what could go wrong. And one of them, specifically number 2, is if the polar vortex develops towards China rather than North America, which would produce a positive NAO or an east-based negative NAO, would basically trap Arctic air over China and Siberia. And that is essentially what happened. Now, the one thing that is a little bit different from this is that also the polar vortex strengthened, which was something that I was not expecting. And the reason why I and many others were not expecting this was because of all of the signs we were looking at. Low solar activity, which is usually a sign that, hey, there's a good chance you're going to see some pretty good stratospheric warming. A shift of the QBO from positive to negative, but not overwhelming negative. So that usually supports the potential for stratospheric warming events. And of course, the above normal snowfall in Siberia, which typically leads to a disruption of the polar vortex in January and continuing on through February. So the idea was with the winter forecast was December was going to start out cold. We get a couple of storms here, and we actually started seeing that. Then we relax a little bit in mid-December, and then the major disruption starts to show up for the end of December and continuing on into January. We get a little break in the middle of January, and then the influence of the Siberian snowfall kicks us over to late January and February being a very active season. And that didn't happen. So if we rule out the tropical forcing, because the active Indian Ocean dipole, that more influences Australia, and what drove a very favorable pattern, unfortunately, for major fires in Australia, that has to do more with the Indian Ocean dipole. It doesn't have a direct influence on our tropical forcing. Now with that, I will say this. Our tropical forcing was slightly influenced, but I don't think enough to make a major difference. The tropical forcing, and I said this from the start, and I still continue to say this, for the winter was not the main driver. It was a significant influence, but it wasn't the driver of the weather pattern. The driver of the weather pattern for this year, I said this back in October, was going to be what's going to happen in the stratosphere and how that would influence the polar vortex. So if something went awry there, then the whole forecast would blow up. So let's take a look at some of the data. Now, this is the Arctic Oscillation observations, and this is from NCEP here. Now, notice as we go through December, everything's going great. I'm very happy with the forecast. We start off where we had a negative Arctic Oscillation. We're marching through November. Then it went positive, and right about the time I thought it would. And then towards the middle of December, hey, look, there comes our crash, and we're ready to roll. Then, right around here is when I'm like, uh-oh, something is not right. And the premium members know I put out a video and a discussion saying something is very wrong here, and if it doesn't change soon, the winter forecast is going to go up like a dumpster fire. And that's essentially what happened. And then you can see the drastic change from where we were at to what happened the rest of January into February. In some cases, almost a historic positive Arctic Oscillation. This also is why whenever you saw a storm showing up 10 days out on the model guidance, I did this a lot in February. I was like, no, this is nonsense. Don't buy it. Anyone who's hyping this is nonsense, because when you have a state like this, you can't have any high latitude blocking. So either a storm has to take a perfect track and the cold air has to be in the perfect location at the perfect time, or it's just going to trend over to rain. Essentially what we saw. So before we continue on, I just want to make clear of our atmospheric layers. Okay, so that way you understand what we're talking about here. This is the troposphere where we all live. Okay, this includes 500 millibars, 850 millibars, all that stuff that we talk about. Here is the stratosphere. Okay, and here's our ozone layer right here. This is the top of the stratosphere. This is the bottom of the stratosphere. Okay, then this is the mesosphere. This is very important. This is where the atmosphere starts to lose some of its density. And then we have the thermosphere right here, which is basically near the edge of our atmosphere. This feature right here is very important in our discussion and explain what happened. It's very interesting. But I just want you to understand the layers here. Mesosphere, stratosphere. Okay? Stratosphere, troposphere. The mesosphere typically doesn't influence too much what happens with the stratosphere below the ozone layer. Typically. Most of the time. Actually, 99.9% of the time. Actually, I'm sorry, 99.9998% of the time. There's a reason why I'm bringing that up. Stand by. And then what happens in the stratosphere influences the troposphere. When the stratosphere warms, okay, it expands, but the stratosphere cannot expand out into space, so it presses down on the troposphere. So when we have warming and it presses down like that, then the troposphere sinks. And that's how you get below normal heights. Okay? Remember that. When it cools, it contracts. So that means the troposphere is able to expand above normal heights. That is a very important feature here. So now, let's take a look at this video. This is from the European model guidance here. It takes all the observations. And I'm going to move this right here for a second here. That way I can click on this. Now this is ozone. Okay, and it shows us, we like to look at ozone to see how the atmosphere is mixing. way up here is the start of our mesosphere. Way down here is the end of our stratosphere and the start of our troposphere. And right here is where we typically start to focus on what's going on with stratospheric warming. Now, notice, let's move right here. Notice what's happening here. You see this dip here? What's happening here is we're seeing mixing pressing down from the mesosphere. A cold pocket. And when I first saw this, I was like, man, that's weird. We normally don't see that. And what that is basically doing, it's the best way to describe it is like adding a steroid to a muscle. It's amplifying everything towards the cold. So you have this cold pocket that's sinking down through the stratosphere here. We can see that very nicely here. And what that's doing is that it is cooling the stratosphere and amplifying the polar vortex. So when I take a look at 70 millibars and take a look at what was happening here, here we are mid-November into December. There's our warming, very excited. And then mid-December, we start to see this change. And also only the cooling happens. It crashes. Now at first, I'm like, okay, I was expecting a relaxation by the middle of December, so maybe it might be a little off by a week. But then by the end of December, I started to see that mixing at 10 millibars. Okay, I'll show that in a minute. At 10 millibars, and I knew what was going to follow at 70 millibars, and there's our crash. And when this crash happened, the polar vortex rapidly intensified, and the winter forecast went kaput. So what happened here, and I'll show this in a couple of the diagrams, is that a piece of cold air, which typically does not get involved in the stratosphere, was able to mix down. Now, how this mixing occurred, my theory, and it needs to be studied, okay? So you have to understand that there's going to be a lot of study involved in this. What I think happened was because of the lack of solar activity, we're seeing a lot of increase in a lot of solar particles hitting the Earth. And I think that was disrupting some of the gravity waves, so the gravity field that we have on Earth. And I think that was disrupting some of the winds that we have up, all the way up towards the mesosphere. Now, this is a theory. It's not proven. I'm just kind of giving you an idea of what I think might have happened here. And when we had that weakness, it allowed for mixing. And that mixing, which is, again, something this is the first time I've actually experienced this. I read something like this could happen in a paper back, I think, I want to say the last year of college, so that's about 2002. There was a paper where it was theorized that something like this could happen, but it never was observed. So we've observed it now. So hopefully there's a whole lot of research on what caused the polar vortex to strengthen. So when that happened, that's when everything fundamentally changed in the stratosphere. And this cold pocket was so overwhelming, and it amplified the polar vortex so much that any other type of interaction, whether it be the Siberian snowfall influence or anything of that nature, you had warming of the stratosphere occurring, but it was coming from such a deep level, it had to overcome so much that it basically was mute in the influence of the weather pattern. So as a result, your polar vortex remained strong, and that melted down into the troposphere, which basically killed any type of high latitude blocking and kept below normal heights down towards the Arctic in the troposphere. Now, I know I'm going to be asked this, so what about global warming? How much of an influence did this have? In terms of the influence of this pattern, and the evolution of it, none. This had nothing to do with that. However, in terms of the air masses that we have and uh, the game, should I say, the playing field has already been altered because we have a warmer state overall. Okay, because of that, I'm being really careful here because I want to be very accurate. The actual environment was not caused by global warming, but the state of the air masses are influenced by global warming in such that when you had a warm Pacific pattern, well, you combine urban heat island effect, the warmer troposphere overall, and also an increase in the precipitable water values in the atmosphere, that would lead to situations where you had above normal temperatures and in some case record breaking. As far as snowfall, below normal snowfall, obviously, because when you have high latitude blocking missing, you're going to have very low snowfall total years, much like 1888 and other years during the 20th century and now 21st century. So basically, it's been one of the warmest winters we've seen. It's certainly in the top 5 in many locations. Some influence from global warming, but the pattern itself was not caused by that. In my opinion, it was caused by the low solar activity because of the mixing we saw in the atmosphere. Now, it shows up really, really well when we take a look at the anomalies here. This is from last year, 2019. Here we are moving along November. Here we are in December. It's our first warming showing up. Getting all excited, getting ready. Got jingle bells going. We got the winter forecast all locked in. Everything looks like it's going great. And then here's our cold pool coming right in, creating havoc, bleeding all the way down into 100 millibars. And that just amplified the polar vortex to a point where it just boom. It became very strong. It became very circular. And so as a result, any type of interruption here via warming just died. And you can also see that very nicely here. You see that bleeding down right here. Look at that. Very, very clear. So I hope you understand exactly what happened with this winter forecast. Quite frankly, this is something that I've never experienced before. It's very interesting to certainly watch. The forecast, I mean, look, I would have loved for it to verify. And I don't think any meteorologist puts out a forecast, well, I hope most, with the idea of hyping a winter. Okay, if you see data and you see everything that's going according to plan, of course, it also is your responsibility that when you see things not going to plan, to let people know. And I think we did that certainly for premium members in late December. And then as things started to evolve, we knew what was going on and we explained it. So that was my responsibility, and that's what I feel that I did. But like I said, I would have loved for this winter forecast to pan out, but it didn't. But at least now we know why it didn't. Whether or not it's something that I could have forecasted for or will be able to forecast for in the future, I really would have to wait and see what some of the research out there says about this winter and what some of the data would suggest, if there was any telltale signs, whether this was just a freak incident or whether this is something that we didn't know about in low solar activity years, unlike in 2009, 2010, where very low solar activity led to one of the most epic winters that we've experienced in the northern mid-Atlantic because of the intense high latitude blocking. Which one is the real influence on the weather pattern? So certainly a lot to learn here. As always, long range forecasting, seasonal forecasting, as always, right now at least, is something that is highly volatile. And a lot of things can go wrong. And I think that if you put that out there in the start of a forecast, and I think that is exactly what I did, then you've done your part, you know. But it's going to be something where these busts are going to happen again. It's just a question of when you see it starting to happen, how fast do you let other your subscribers and even the general public know, okay, things are not going to plan, and here's what to expect now. So that is the video I promised. I hope you guys enjoyed it. I had to split into two parts because it got a little long. But I hope you enjoyed it. And hopefully next winter's forecast will be a lot better than what we saw. Okay, thank you and have a wonderful afternoon.